Hi there, my name is Mannat and I'm going to show you the hot ice demonstration. For this demonstration, I will be using the following materials: a hot plate, sodium acetate trihydrate crystals, test tubes, a dropper, some water, a glass container, a beaker, and a skewer. Disclaimer: this person is a trained scientist who has all the required personal protective equipment necessary. Please do not attempt this at home. So here I have 4 test tubes. One of them is filled with quite a bit of sodium acetate trihydrate crystals. One of them is also filled with the same but much less right here. I have another test tube just filled with water and another test tube that just has a skewer that will act as a stopper for now. So here I have my skewer. I'm just going to dip the tip of it inside this water, inside this test tube here. And then I'm going to dip it inside this little batch of sodium acetate trihydrate crystals. I'm going to take it out and put it back in here. We're going to use that later on in the experiment and you'll see why. So here I have this other test tube filled with sodium acetate trihydrate crystals. I'm going to take a dropper and just add a little bit of water to it. Not a lot, just very little. That's all. Now I'm going to take this and just add it inside a big beaker filled with water to boil it. As you can see, the sodium acetate trihydrate crystals have clearly dissolved inside here since there's a very clear, completely clear solution inside here. So I'm going to turn the hot plate off and it's going to stop boiling over here. So I'm going to take this out and you can very clearly see that it's become a completely clear solution inside, and then the sodium acetate trihydrate crystals have dissolved. So I have my clear saturated solution of sodium acetate crystals here. I'm just gonna pour it out onto this clear dish, this plate over here. That is good. So here, as you can see, the sodium acetate trihydrate crystals have completely solidified. Like if I try moving it around with a skewer, it's completely solid. Like it's not liquid anymore and it's not just a color change. And these are our crystals. This demonstration shows us how chemicals absorb energy and respond to it. Every substance is made up of little particles that are always moving or vibrating. This tendency of the particles to move determines their temperature. If the speed with which they move changes, then this is what we call a change in their temperature. The more the little particles move around, the hotter the substance is. So in a solid, the particles stay in the same position, like ice. But when we add energy to something that is solid and then it becomes liquid, the particles inside the solid move more as their temperature increases. So in a liquid, the little particles move around more than if they were in a solid. In this case, the process of adding energy to a solid to make it a liquid would make it an endothermic reaction. since the energy went inside the substance to make its particles move around more. An example of something solid would be crystals. They are made up of little particles that stay in the same place. But when we place them in heat, their particles absorb energy. This is an endothermic reaction, and it makes the particles move around more. So they become liquid. That's a transition from a solid with fixed particles that takes energy and turns it into a liquid with moving particles. After this, we moved the liquid crystals and cooled them. They were less heated and cooler. Their temperature decreased, and so their particles moved around less. This would make them solid with particles in a fixed plate. So when crystals are supercooled, they've basically forgotten how to go from a liquid state back into a solid state. But there's a way to remind them how to do it. Whenever they touch something solid, such as the clear plate or the skewer with the crystals on it, the solid crystals touch the liquid crystals and act as an example.
Thank you for watching the hot ice demonstration. Enjoy the rest of your time at FUNweek.